So this is the 46th session on relative velocity. In this I will take up a question on phase 2 of case 2 of relative velocity problems for mutually translating frame. For knowing what is case 2, you just refer to 40 seconds video of relative velocity, 40-second session. There you get details of phase 2, case 2 also. Okay. First I'll just write down case 2 is what, then I'll continue. So in this problem is this. This is a frame F. M is some other frame. M is translating with respect to F. P is a moving point being observed simultaneously from frame M and F both. Then we write down VPF equal to VPM plus VMF. Now in case 2 problems, case 2 as I'm just stating it here. You can refer to that also. 40-second video you will get the details, but still I'm stating it here also. Case 2, VPM is known completely in magnitude and direction both. VMF is also known completely in magnitude and direction both. Problem will revolve around finding this VPF in magnitude and direction both. Okay. So this is the case 2. Okay, fine. So I will, in this it's just simple addition. If you add these two velocities, we get VPF. And once VPF is known, problem is then easily solved. Okay. So now I'll take a problem on this phase 2. I'll write down the problem here. Okay. So I'll write down the question. It's something like this. There is a straight river which flows towards east. At a constant speed u with respect to ground. S is a swimmer whose speed with respect to river is v, and v is given to be more than u. P1 and P2 are two vertical poles fixed in the river bed. Fixed in the river bed and are separated by a distance L, and P2 is due east of P1. The swimmer swims from P1 to P2 and then back to P1. Swims from P1 to P2 and then back to P1. Find the time taken by the swimmer for the complete journey. Find the time taken by the swimmer for complete journey. Okay, in terms of L, U and V. This I'll rub it, okay? This also I'll rub it, okay? Okay, so I'll draw the diagram. Okay, I'll draw the top view. I have to draw the top view of the situation. Top view, okay. In top view, this is the river. It is flowing eastward at a constant speed u. P1 and P2 are two vertical poles fixed in the river bed, separated by a distance L, and P2 is due east of P1. Now we identify the frames and object. The object under consideration is swimmer, which is denoted by S. Instead of frame M, we have the river frame, which is denoted by R. Instead of F, we have ground frame, denoted by G. Now we write down the vector equation. VSG is equal to VSR plus VRG. Now VRG is given to be U rightward, eastward, complete information given. VSR is also given to be V with respect to river. While in P1 to P2, VSR is rightward, and in P2 to P1 it is leftward. So this is also known fully. The problem revolves around finding VSG. Okay. So now question is how to find the time taken by the swimmer for the complete journey. That is the question. Alright. So how to find that time, that is the question. So we start from here. Let T be the total time taken by the swimmer. By the swimmer. So T is the total time taken by the swimmer for the complete journey. That is the sum of T1 plus T2. Where T1 is the time taken by the swimmer to swim from P1 to P2. And T2 is the time taken by the swimmer to swim from P2 to P1. So now to find T, we have to find T1 and T2. Now the question is how to find T1. Swimmer swims from P1 to P2. So with respect to ground frame, swimmer covers a distance L at a constant speed of say VSG1. So T1 will be equal to L by VSG1. Now what is VSG1? VSG1 is the speed of swimmer with respect to ground while swimming from P1 to P2. Now to know T1, we must know VSG1. Now how to find VSG1? We write down the vector equation as I wrote down here. VSG1 is equal to VSR, that is vector V plus vector VRG plus vector U. Now in this case V is also rightward, U is also rightward. So both are rightward. So this is the vector sum. Magnitude of this is simply V plus U from the law of parallelogram, law of vector addition. So VSG1 will be replaced by V plus U. So T1 will be equal to L by V plus U. This is T1. Alright. Now we have to find the value of T2. T2 is the time taken by the swimmer to swim from P2 to P1. Again, when the swimmer swims from P2 to P1, with respect to ground, swimmer covers a distance L at a constant speed of say VSG2. So time taken will be distance by speed. Speed is simply VSG2. Now how to find T2? To know T2, we have to know VSG2. L is already known. We only have to find the value of VSG2. The question is how to find VSG2. For again write down the vector equation. VSG2 is equal to VSR plus VRG. Now VRG is again U eastward, and in this case VSR should be V westward. Then only person will return. So VSG2 is simply vector sum of these two. They are opposite directions. Now VSG2 either will written as V minus U or U minus V. But since person is going toward leftward, so V is greater than U. So VSG2 should be written as V minus U and not U minus V. So VSG2 is substitute here. This will become L by V minus U. Okay. If we add these two, we get T. So T is equal to what? T is equal to T1 plus T2. L by V plus U plus L by kya? V minus U. That becomes 2LV by V square minus U square is the required answer. Alright. So time taken by the swimmer for the complete journey will be 2LV by V square minus U square. Fine. Alright. So this is the time taken by the swimmer for the complete journey to swim from P1 and to P2 and then back to P1. So it is necessary that V should be more than U. Otherwise the swimmer will not be able to return. Because if U happens to be more than V, then when person will try to return, but the river will cause him to drift further towards east. He can't return to P2. So V should be more than U for return journey. For going from P1 to P2, anything. V happens to be more than U or less than U, doesn't matter. But return journey, it is necessary that V should be more than U. Okay, fine. I'll rub it. This I'll rub it, okay? Now I'll take another question on this case 2, okay? Second problem is this. A man walks up a stalled escalator in 60 seconds. A man walks up a stalled escalator in 60 seconds. When standing on the same escalator, now moving, he is carried up in 30 seconds. What will be the time taken by the person? What will be the time taken, by the person to walk up the stalled moving escalator? To walk up the moving escalator. This is a question mark. Okay, fine. So now, first of all, we identify the object and frames. Object under consideration is the person, man, denoted by P say. Instead of M frame, we have escalator, denoted by E say. Instead of F frame, we have ground, denoted by G say. Okay. Now, escalator, I hope you know, it's well known. Moving stairs, which you see in airports, in railway stations, in malls. Moving staircases, you can start this, just stand on the moving escalator to take you upward, or if it will carry you downward, whatever it is, okay. So now, this is the escalator, okay. Side view of the escalator. It is moving upward with some speed, okay. And person is walking up this moving escalator. Person is walking up this moving escalator. How much time will it take the person to walk up the moving escalator? Suppose the person covers a distance L with respect to ground in going from top to bottom of the escalator. Top to bottom, okay. So time taken will be distance covered by the person while going from here to here with respect to ground, that is simply L, divided by speed of person with respect to ground. Divided by speed of person with respect to kya? Ground. So T is equal to L by Vpg. Now to find T, we have to know Vpg. Vpg is the speed of person with respect to ground. Now to find T, what we have to do? We have to know Vpg. To know Vpg, I write down the vector equation for translating frames. So Vpg is equal to Vpe plus Veg. Alright. So to know Vpg, we have to know Vpe, we have to know Veg. Alright. I'll rub this, okay. Now we have to know VPE and we have to know VEG. VPE is the speed of person with respect to the escalator, and VEG is the speed of escalator with respect to ground. So we have to know VPE and VEG. Okay. Now how to find VPE? That is the question. How to find VPE? That is how to determine this VPE. Now it is given that the person walks up the stalled escalator in 60 seconds. है ना? Stalled escalator meaning what? Static escalator. So this is to know VPE. Suppose this is a stalled escalator. Stalled escalator means VG 0. In that case, person walks from here to here, L distance. It takes him 60 seconds to move from here to here. So in this case, stalled escalator, in that case of stalled escalator, this goes away. VPG is just equal to VPE. So in this case, how much will VPG be? L by 60. That is also VPE. But now we have to find VPE for this case, moving escalator. See, here we have to make a very basic assumption that person runs in both the cases on this stalled escalator and moving escalator with the same force. Okay, he applies the same force to walk up this moving escalator and to walk up this stalled escalator. This means that VPE for this case is also VPE for this case. Is it clear what I have said? Huh? I'm trying to say that the time taken by person to move of the stalled escalator is how much? 60 seconds. Velocity of person with respect to ground in this case becomes L by 60. That is also VPE. Now I'm assuming that the person runs on this moving escalator with the same force as it does in this case. So in this case, whatever VPE will be, same VPE will be for this case also. So in this case also, when person walks up the moving escalator with the same force as it does in the static case, so this case VPE, this is also the VPE for the second case. So VPE will be written as again L by 60. Now VG is what? Velocity of escalator with respect to ground. Now it is clearly stated, person is carried up in, standing on the same escalator, he is carried up in 30 seconds. So velocity of escalator with respect to ground will be L by 30 seconds. Now these two are in same direction. So VPG will be simply the magnitude of these two vectors because they are in same direction, parallelogram law of vector addition. So that becomes L by 60 plus L by 30. This is VPG. Now we substitute VPG in this formula. Then we get the time, required time. So T will be equal to L by VPG. VPG becomes L by 60 plus L by 90. Sorry, 30. Sorry. L by 60 plus L by 30. L goes away. This will become 60 into 30 by 90. So this will become 20 seconds. Answer will be how much? 20 seconds is the required answer. Answer will be equal to 20 seconds. This is therefore the required answer. Fine. So person will walk up the moving escalator in 20 seconds. He will be carried up in 20 seconds. Alright. So this problem also I have discussed. Fine. Now I'll take up one more question on phase 2. Okay. I'll take up one more question on case 2. This will end of this session. Okay. Third question. a ship S moves eastward at a constant speed of 40 km per hour with respect to G meaning ground. An observer on the ship observes a submarine to move north at a speed of 30 km per hour. An observer in the submarine observes a helicopter to rise up at a speed of 20 km per hour. Find the speed of helicopter with respect to ground. Okay, fine. This is the question. Find the speed of helicopter with respect to ground. Fine. So first what we do, we identify object under consideration. Object under consideration is helicopter, which is denoted by H say. Then for the frames we have the submarine frame denoted by M say. Then we have the ship frame denoted by S say. Then we have the ground frame denoted by G say. Now I have to find the speed of helicopter with respect to ground. So we start from here. Velocity of helicopter with respect to ground is velocity of helicopter with respect to submarine plus velocity of submarine with respect to ground. Velocity of helicopter with respect to ground is equal to velocity of helicopter with respect to submarine VHM plus velocity of submarine with respect to ground. That right is velocity of submarine with respect to ship plus velocity of ship with respect to ground. Okay, so VHG is the vector sum of these three velocities. Okay. Now, I'll just say for convenience, I will take a coordinate system. I'll show this in top view. Okay. This is the x-axis eastward. This is y-axis northward, and upward direction of this. Is it clear? Top view. X-axis rightward, eastward, y-axis northward, and z-axis upward. So this VHM, velocity of helicopter with respect to submarine, how much is it? Rise up at a speed 20 km per hour. So this becomes 20 k hat plus velocity of submarine with respect to ship. That is how much? 30 km per hour. 30 along y-axis. 30 j hat plus velocity of ship with respect to ground. 40 km per hour along eastward direction. 40 I hat. Alright. So now VHG is the vector sum of these three. And from law of vector addition, VHG magnitude of VHG will be 20 square plus 30 square plus 40 square. This will become 2500 plus 2900. This will become equal to 10 root 29 kilometer per hour, which is therefore the required answer. Fine. So velocity of speed of helicopter with respect to ground is equal to 10 root 29 kilometer per hour. This is therefore the required answer. In this 46th session, I have taken problem on 3 problems on case 2 I have discussed. Okay. In the coming few sessions, I will take a further problems on case 2. I will take up the riverman problem. I will take 2 or 3 videos on that riverman problem. All types of problem I will discuss. Okay. Then I will pass over to set 3, case 3. Okay. So I think roughly around 60 to 70 videos will be there on relative velocity. Complete for board level, mains level, advanced level, total complete. If you go through all of these videos, then you are bound to solve all the questions which come in JEE Mains Advanced and NEET also. Fine, I'll close it here itself. All right, that's all. I'll close it.